Hey guys, this is the trig portion of our review. We're going to look at the chapters 13 and 14 from the book if you're using that. We're not doing all of that, but there are some big chunks in there that we're looking at. In your review pack, this is 7, 9, 12, 14, 17, 19, 20 through 23, 28, 29, 31, 37, 41, 42, 44 through 53, and 70 through 78. As you might imagine, there's no way that I'm going to go through all these problems, but I'll try to do a bunch of these to make some sense of them. First up, we've got a diagram. We've got to identify which equation is correct based on the sign of this angle. I'm going to label my opposite, my hypotenuse, and I don't even know why I said the sine of this angle. So based on this angle, and my adjacent, sine is going to be, I'm going to actually write these out. So sine of theta is opposite, I don't know what that is, over hypotenuse. So that'd be question mark over 5, and, well, that's not either of these, actually. So definitely not sine, okay? Cosine of that angle is going to be adjacent, so 4 over hypotenuse, 5, and that's choice C. The approximate value of the angle in this triangle, so we've got some kind of angle here. I'm going to label my sides as opposite, hypotenuse, and adjacent. We're looking at, we know opposite, we know hypotenuse. That's going to be sine O over H. So sine of theta is equal to 5 over 13. To get that angle by itself, we're going to use that inverse button. So sine inverse of 5 over 13. I'm going to do a quick check to make sure we're in degrees. And when I do that, I get sine inverse of 5 over 13 is about 22.6, which happens to be B. Next up, we've got to solve for x based on this angle. We've got the opposite, the hypotenuse, and the adjacent. Well, we know the opposite. We want to know the adjacent. I know that tangent is going to be the opposite over the adjacent. I know I've got to multiply by x to get out of the denominator. And if I were to divide by tangent of 40, we get an answer of x is equal to 6 divided by the tangent of 40. When I do that out, we get x is equal to 7.15. And in looking through my answers, that appears to be answer D. For number 14, we're converting 17 over 18 pi into degrees. That's going to be 17 over 18. I'm going to put the pi up top because it's easier for me to work with. And I know that in a circle there are 360 degrees, and there are 2 pi radians. I'm going to put the 2 pi on the bottom because I know I've got to get rid of that pi to go into degrees. Those are going to cancel out. I know that 360 and 18 both can be divided by 18. And I'm left with 17 over 1. We've got 20 over 2. And I also know that 20 divided by 2 is going to be 10 over 1. 17 times 10 is 170. Here we're going to find x. We're going to use some trig to do that. So I've got an angle. Here's my opposite. Here's my hypotenuse. And here's my adjacent. I know my hypotenuse and I want my opposite. That's going to be sine. Sine of 37 degrees is equal to x over 22. When I multiply both sides by 22, I get my answer. So we got 22 sine of 37, and that's going to be x equals 13.23 or 24 degrees. And that's going to be C. Convert 72 degrees to radians. Just like we did before, we've got 72 degrees. We're going to multiply that by, in this case, 2 pi radians in a whole circle. divide by 360 degrees in a whole circle. I might do some reducing here. So we've got 1 over 180. I know both these can be divisible by 2. That's going to be 36. And this is going to be 180 divided by 2 is 90. I could go by 9 this time, and I've got 4 left, and I've got 10. So I'm just going to rewrite this now. I'm getting confused. So we get 4 times pi over 10. I can reduce that to 2 pi over 5. And in here, that's going to be answer choice C. For number 20, we've got, actually for 20, 21, 22, 23, some kind of triangles we got to solve. I'm going to choose a couple of these to do out for us. So I've got ABC with small a is equal to 7. Big C is going to be 37 degrees. Big B is going to be 18 degrees. Pretty quickly, I can find angle A because I've got 2 out of the 3 angles, so 180 minus 18 minus 37. 180 minus 18 is going to be 162. Minus 30 is going to be 132. Minus 7 is going to be 125. This is not a right triangle, therefore I have to think law of sines or law of cosines. In this triangle, I've got opposite pieces, so we can use law of sines for this. And I know I'm trying to find C, so I'm trying to find that side. So sine of 125 over 7 is equal to sine of 37. That's angle C over side C. In doing this out, so we've got sine of 125 divided by 7, 0.1141. Sine of 37, they love that angle, is going to be 0.6018. And that's going to be divided by C. I'm going to multiply both sides by C to get C out of the denominator. And then I'm going to divide both sides by 0.1141. 0.6018 divided by 0.1141 is going to be C is equal to 5.27, which is not any of those choices. And that's because when I typed in sine of 125 divided by 37, I typed in sine of 127 over 7. So this, instead of 0.1141, should be reading 0.1170. And instead of 5.27, I bet you can probably predict we can get the one that's really close to that. We get 5.14. And look, that's the one that's really close to that answer. I'm going to skip 21. Let's take a look at 22. So we've got ABC again. And here we know that B is 2. We know that C is 4. And that measure of angle A is 118. All right, I'm going to try law of sines first. I don't seem to have any opposite pairs, which is not what I'm looking for. If that doesn't work, I've got to use law of cosines. I'm trying to find A, so I'm going to use law of cosines to set up with A. So A squared is equal to B squared. That's going to be 2 squared plus C squared. That's going to be 4 squared minus 2 times B is 2 times C is 4. Cosine of 118. I can literally type this in and evaluate that. So we get 4 plus 16 minus 16 cosine of 118, and I get a squared is equal to 27.5, which means A is equal to about 5.24, which is really close to A, just a rounding difference. I'm going to skip 23. For number 28, I'm going to use my special right triangle, and we're looking at a 30-degree angle. And with regards to this, on your reference sheet, you have a special right triangle with a 30-degree angle. And the side lengths is marked on here are going to be y the square root of 3, 2y, and y, although we could also use unit circle for this. I know that cosecant is the reciprocal of sine. So one of the ways to do this is to find sine of 30. In other words, if we're looking at our triangle, opposite over hypotenuse. So that's y over 2y, which you might recognize is the same thing as 1 over 2 because the y's can cancel out. That means that cosecant of 30 would be 2 over 1 or 2. For cotangent of 45, I'm going to use special right triangle again. I could also use the unit circle for this. But we're looking at a 45, 45, 90 right triangle. Using your reference sheet, that's going to be written as x, x, and x root 2. Cotangent is the reciprocal of tangent. I know that tangent of 45 is going to be opposite divided by adjacent. So that's going to be x over x, which is 1. The reciprocal of 1. So the cotangent of 45 is going to be 1 over 1, or just 1 also. Converting 220 degrees to radian measure. Okay, so I know I've got to go from degrees to radians. I've got to add in a pi and get rid of the degrees part. So I'm going to use the scale factor 2 pi over 360. I know in a circle, we've got 2 pi radians, we've got 360 degrees. I also know this is 220 over 1. And I'm going to see what I can do to reduce some things before I do some multiplication. I might start by realizing I could change this to 1 and 180 by dividing both of those by 2. I might also realize that I could divide both of these by 10 to get rid of the zeros on the end. And I'm going to rewrite this now as 22 times pi, or 22 pi. And on the bottom we have 18. I can reduce that by 2 again, so we get 11 pi over 9, and that's my final reduced answer. For number 37, we've got a trig word problem, a ladder. Okay, it's leaning against the store. So if I've got a store here, if the ladder is leaning against the store, it has a 53-degree angle with the ground. Okay, I can turn this into a triangle. My ladder is my hypotenuse. And what we want to know is how far up the store that reaches. I also know the ladder is 16 feet long. And with this information, I can begin to set up a trig ratio. So looking at this angle, we've got opposite hypotenuse. We want to know the opposite. We know the hypotenuse. I could write this as sine of 53 degrees is equal to y over 16. 16 times sine of 53 is equal to y. And actually, you're welcome to leave your answer like this and get full credit for it. If you'd like to go a little bit further, you could do 16 times sine of 53, and I get 12.77 feet. This is supposed to be to the nearest tenth, so that would be 12.8 feet. '41, we've got a triangle. We're given some information and asked to find B. So we're given a triangle ABC where A equals 3, angle A equals 40, angle B equals 27, and we're asked to find B. I can see this is a nice setup for law of sines. And in setting this up, I'm going to write this as sine of 40 over 3 is equal to sine of 27 over B. So I'm going to multiply both sides by B. I'm going to calculate this decimal out, so let's do that now. So sine of 40 divided by 3, we get B times 0.2143. That's equal to sine of 27. I'm going to calculate that out now too. 0.45399. So I'm going to leave that like that. If I divide by 0.2143, we get B is equal to 2.1184 as my answer. 2.12 would be 2 decimal places. 42, we're going to find angle A in a triangle given 3 sides. As soon as I see that, I want to think log cosines, but let's draw this just to show that. So we've got ABC, and we've got A is equal to 12, B is equal to 19, and C is equal to 21. I'm looking for angle A. That's what I want. We don't have any opposite pairs, so I can't use law of sines for this. Use law of cosines focused on A, since that's what I'm looking for. So that would be A squared is equal to B squared plus C squared minus 2BC cosine of angle A. Plugging things in, A squared is going to be 12 squared. B squared is 19 squared. C squared is 21 squared. Minus 2 times 19 times 21 times cosine of A. Big idea number 1. I'm trying to get this by itself. And in order to do that, I've got to get rid of everything else on this side. Big idea number 2, and the thing to be careful about is that this stuff is multiplied by cosine of A. You cannot combine that with the other numbers here. So we're going to get rid of these two by subtraction first, and then do some division to get rid of the stuff over here. All right, so first up, as I said, we're going to talk about getting rid of these guys. And what I'm going to do is take 12 squared, so 12 squared, which we know is 144. So you get 144. 19 squared should be 381. 361. Whew. I'm glad I actually checked that. 21 squared should be 441. Good, at least I'm not totally off today. And on the other side, I'm left with negative 2 times 19 times 21. So negative 798 cosine of A. On the left side, if I do that calculation, 144 minus 361 minus 441, we get negative 658 is equal to negative 798 cosine of A. When I do that division, so divide by negative 798, we get cosine of A is equal to 0.8246. To get angle A, we're going to do the inverse cosine. So we're going to do cosine inverse of 0.8246. And we should get something like 34.46 degrees. For 44, to write sine of A as a fraction in the lowest terms, all we're doing is labeling our triangle with opposite, hypotenuse, and adjacent, realizing that sine is opposite over hypotenuse. That's going to be 5 over 13. For 45, to find x to the nearest hundredth, Based on this angle, we've got adjacent and we've got hypotenuse. So this is going to be a cosine function. So we're looking at cosine of 33 is equal to x over 12. When I multiply both sides by 12, that's going to be 12 times cosine of 33 is equal to x. So 12 cosine 33 is going to be x equals 10.06. Cotangent of 60, we're going to use a special right triangle again. And looking at the special right triangle we have for 60 degrees, again, this is just from your reference sheet, so that we're speaking the same language. That's going to be y square root 3 across from the 60. That's going to be y across from the 30. And then we're going to have 2y across from the 90-degree angle. That's the hypotenuse. Cotangent is the reciprocal of tangent. So it might be easier for us to find tangent first. That's opposite, that's adjacent, that's hypotenuse. And tangent of 60 would be y square root of 3 over y. The y's cancel out, leaving you with just square root of 3. Cotangent of 60 would be, if this is the square root of 3 over 1, cotangent of 60 would be 1 over the square root of 3. If you want to rationalize the denominator, we can multiply the top and the bottom of this by the square root of 3. And another acceptable answer would be the square root of 3, and root 3 times root 3 would be 3. Either of these answers would be totally acceptable for this problem. 47 we're going to skip because we just did like 3 problems like this. We're going to jump to 51. And in looking at that, so 5 pi over 12 radians to degrees. 5 pi over 12, going from radians to degrees, the 2 pi is on the bottom, 360 is on the top. I'm going to do some reducing before I do some math. 360 over 2 is going to be 180 over 1. I know I can divide both the 180 and the 12 by 6. And when I do that, I get 30 over 2. I'm going to rewrite this because now this is getting messy. So that's 5 pi times 30 over 2 times pi. My pi's cancel out. 5 times 30 is 150. Divided by 2 is going to be 75 degrees. For these guys, we're going to find some coterminal angles. I'm also going to find some reference angles to go with this just to kind of keep that on the same page. Looking at 71, we've got 111 degrees. A positive coterminal angle would be 111 plus 360. In other words, that would be 471 degrees. A negative coterminal angle for this would be 111 minus 360. That'll take us satisfactorily into the negatives. And 111 minus 360 is going to be negative 249 degrees. In terms of reference angle, what we're talking about here is what is the angle with the x-axis. In looking at this, 111 degrees goes past 90. That means that the reference angle here would be whatever angle it makes with the axis here. To get that, that'd be 180 minus 111, and that's going to be something like 69 degrees. Okay. 72, we're going to follow the same type of path. Negative 111, I'm going to add 360 and see if that gets me above 0, and that gets me to positive 249. Negative 111, another negative angle would be minus 360. That's going to get me to negative 471. I'm going to close that area off. I'm going to do the same thing in terms of finding a reference angle, just so we can talk about knowing how to do that. So negative 111 is going to go past negative 90 and end up down here. Again, we're trying to make the angle with the x-axis. That would be negative 180. So if I'm trying to get from negative 111 to negative 180, we got to figure out how to get there. Negative 111 is the bigger number. So we do negative 111 minus negative 180. And in doing that, we get 69 degrees again. If you'd gotten negative 69 degrees because you subtracted those backwards or you figured this out another way, just know that reference angles need to be positive angles. For number 73, 3 pi over 4, to get to another positive coterminal angle for this, I'm going to add 2 pi. So in doing that, I might rewrite this as 3 pi over 4 plus, and 2 pi is going to be 8 pi over 4. That reduces to 2 pi. And when I add those together, I get 11 pi over 4. To get a negative value, we're going to do 3 pi over 4, and I'm going to do minus 8 pi over 4, and that's going to get me to negative 5 pi over 4. For the reference angle part, I need to figure out where in my circle this fits. So if 0 is here, pi is here, a half pi is up top. This is 3/4 pi. So 3 pi over 4, 3/4. I'm going to go 3/4 of the way to pi, and my angle is up there. I've got to figure out what that angle is. And looking at this, so that's going to be pi minus 3 pi over 4. That would be 4 pi over 4, and the answer is 1 pi over 4 when I subtract those two. That's my reference angle. I'd like you to notice my reference angle was the same as the denominator in that fraction. For number 74, negative 5 pi over 6, I've got to add 2 pi to this, and in terms of 6, that would be 12 pi over 6, which gives me 7 pi over 6 as a coterminal angle. Similarly, negative 5 pi over 6 minus 12 pi over 6 would be negative 17 pi over 6 as my negative coterminal angle. For a reference angle, negative 5 pi over 6, that's a little bit before I get to negative pi, because 5/6 is really close to 1. So we're talking about going almost all the way to pi in the negative direction. That'd be negative pi going this way. My reference angle, again, would be this value in here. And if I do negative pi, so let's do 6 pi over 6 minus negative 5 pi over 6, I end up at negative 1 pi over 6. We mentioned a few minutes ago that it has to be a positive value. So what we're really talking about is the absolute value of this. So pi over 6 would be the reference angle. I'd also like you to notice that pi over 6 is the same denominator as the angle that we started with. Next up, we got a graph y equals negative 4 cosine of 4x. Big thing I need to figure out. I'm just going to do one period of this. I'm going to do the positive period. But the first thing I need to do is to establish what's going on here in terms of graph shape. Cosine starts at the top, goes down, and comes back up. This should be from 0 to 2 pi normally, which means that pi is in the middle. This would be pi over 2, and this would be 3 pi over 2. Okay, that's the basic graph that I need to think about when I'm doing this. My midline, we're doing plus 0, so that's going to be 0. It looks like this middle line is supposed to be a y-axis. I'm going to actually do that over here, just so that I can draw the positive part of this graph a little more easily. I also don't have a scale here, so once I figure out what points I should be using, I'm going to add that scale in. Next thing to do is take a look at the amplitude, and I'm going to go 4 up and 4 down from my midline. 1, 2, 3, 4. 1, 2, 3, 4. Just to put some boundaries in. Okay, I'm going to take the inside and now use that to find critical points on this graph. So if I've got 4x is equal to 0, that tells me my starting point. That's up here. That means that at x equals 0, I'm going to have that high point. That high point is going to be on my amplitude mark up top. Except I just screwed that up a little bit because this is a negative graph. So instead of starting at the top, we got to start at the bottom. Negative out front means we're going to flip the entire graph vertically. Okay, I'm going to change colors just so we can see these things separately. And I'm going to look for the other endpoint now. The other endpoint happens when x equals 2 pi. So I'm going to take the inside 4x, and that's equal to 2 pi. When I solve for x, we get x is equal to 2 pi over 4, which is the same as pi over 2. And that's going to be, should be up top, but based on my negative, that's going to be at the bottom again. And I'm going to choose a number that's going to be pretty easy to work with, that I can divide things out pretty easily. So let's go 1, 2, 3, 4. And that's going to be my pi over 2. That means that right in the middle, we're going to have pi over 4, because a fourth is half of 2 pi. I'm sorry, a fourth is half, it's pi over 2. And then we're going to have pi over 8, because that's between 0 and pi over 4. And you might know that 3/8 comes between a fourth and a half. Or you could do pi over 4 plus pi over 2 and divide the result by 2. Okay, I've gotten 2 of my points. I'm going to get my third point 2 different ways. That's going to be the middle point, which on my original graph is going to be on the bottom. Because we're flipping it with a negative, it's going to be up top. I could think about this as cutting these 2 points in half, and I'm going to go in the exact middle of those, go up to the top, and there's my third point. If you'd prefer, you can do this with an equation too. This is supposed to be at pi, so 4x is equal to pi, and I get x is equal to pi over 4 when I solve for that equation. And that works out because pi over 4 is exactly what I figured out in the middle there. For cosine, the remaining 2 points are going to be exactly in the middle of our graph on either side of these, the point that we just plotted. If you'd prefer, you could also set these up as equations too and do 4x is equal to pi over 2 for the first one. When I divide by 4, a half divided by 4 is 1/8. We get x is equal to pi over 8. So that would give us that point as well. And again, you could set this other one up and do 4x is equal to 3 pi over 2. When I divide that by 4, in other words, multiply it by 1/4, I get x is equal to 3 pi over 8, this other point that we established. You don't have to do that. You can just cut these distances in half. I would like to see some nice smooth curves here. I really would rather not see a pointy graph. But once you do that, you are done. Dealing with f of x is equal to 4 cosine of pi x over 3. We're going to do the same thing here. First thing, this is plus 0. I'm going to do the positive part, so I'm going to make a new y-axis. Here's my x-axis, nice in the middle. My midline is going to be at a height of 0. And then I'm going to start graphing this thing. We've got an amplitude of 4, so 1, 2, 3, 4. I'm going to draw some amplitude points in. 1, 2, 3, 4. Now I have boundaries in which to draw my graph. Again, I'd like us to remember that cosine looks like this. We've got endpoints at 0 and 2 pi for the first cycle of my curve. And right in the middle is going to be pi. Between those two, you can cut those in half again and get pi over 4. And 3 pi over 8 for your x values if you so desire. Let's go for this first point, this peak first. Since we're positive, we're going to start at the top of the graph. I'm going to set the inside of my cosine function So pi x over 3 is equal to 0. I'm going to multiply by 3 and divide by pi, and oh, I still get x is equal to 0. That means my first point is going to be up top at 0. Second one, I'm going to look for my other endpoint next. I'm going to do this one in an orangey color, and we're looking at pi x over 3 is equal to 2 pi. Multiply by 3, and we get pi x is equal to 6 pi. Divide by pi, and we get x is equal to 6. That's kind of weird. We're used to having pi's in there. So I'm just going to go over 6. 1, 2, 3, 4, 5, 6. And I'm going to go up to the top, and that's my second point. Okay, well, exactly between those 2 points is going to be 3, and based on my understanding of the cosine mother function, this is going to be at the bottom of my cycle. The other 2 points I can get by going exactly halfway between 0 and 3, or 1.5, and exactly halfway between 3 and 6, or 4.5. Those 2 points are going to sit on the midline. That's these 2 guys. I could also get those by plugging in the equations, but I don't necessarily need to. My cycle looks like this. For number 77, we're going to graph f of x is equal to 6 sine of x over 2. First thing I might do is to sketch a basic sine mother function. The positive piece looks like this, and we know we're starting at 0. We're going to 2 pi. Pi is in the middle, and between these two would be pi over 2 and 3 pi over 4, except that's not 3 pi over 4, and that's 3 pi over 2. Whew, sorry, my brain's a little bit fried right now. I'm going to just do the positive piece of this again. I'm going to note that this is plus 0. So my midline is going to be at 0. I'm going to realize that my amplitude is going to be 6. 1, 2, 3, 4, 5. I can't do 6 on here using 1. So I'm going to set each y is equal to 2. And do these at -6 and at +6. Yay for small graphs. Okay, I'm going to find my 0 point first. Set the inside, x over 2 is equal to 0, and I get x equals 0. No phase shift here. I'm going to find my second endpoint. X over 2 is equal to 2 pi, and when I solve that, I get x equals 4 pi. I might find something that's divisible by 4. 1, 2, 3, 4, 5, 6, 7, 8. Sure, that sounds good. That gives me a nice spread out graph too. And that means that halfway between there would be 2 pi, 1 pi, and 3 pi, just to mark my graph a little bit up there. Exactly halfway between these 2 endpoints, I'm going to have that middle point also sitting on the midline. Based on my graph here, I'll do this one in that orangey color, that should be 2 pi. Since we're looking at a positive cycle, we're going to go up first. I'm going to go halfway between these 2 points and go up to the top of my graph to get my first bend point. And do the same thing at 3 pi, except going to go down to the bottom to get my second maximum endpoint. Draw a nice smooth curve. We get something that looks like this.